in this video, what we're going to do is take a close look at the difference between value data types and reference data types. This is going to become very important to you later on when you need to start focusing on creating efficient code. But for now, it's going to be important because you need to have an understanding of the two different types of data for the simple fact that you may find yourself working with a variable that is not responding the way you think it should be responding, and that is because you are lacking this understanding. So that's the goal of this video. Now, in the last video, we took a bit of time and looked at a lot of the predefined data types that the C# language makes available to us. There were quite a few of them. We looked at ints, floats, decimals, strings, object. The list went on and on. Well, at the very beginning of that lecture, I had mentioned that data types break up into two categories. We have value. So even though I wrote this out before, let's do it one more time. And we have reference. So a value data type and a reference data type. Now with the value data type, I had explained an integer. That is a value data type. What it does is it stores the actual value in the memory location. So if I was to create an integer I and assign it 5, you would actually find 5 in that memory location. For a reference, on the other hand, let's say I had created a player game item object, and what we would find inside of player would be a reference pointing to another location in memory where the actual game item object would exist. Simple as that. Okay? So a very big difference between the two. Value, you're going to find an actual value in there. Reference types, you're going to find a reference being stored in that variable pointing to another location where you will find your actual object. All right? Well, that's pretty clear cut, huh, Logan? We're done.
Yeah, it looks simple enough. I mean, you've got storing a value and storing a value somewhere else.
Exactly. But I'd like to take it a little bit further than that. Let's show you guys exactly what's happening under the hood. Okay, let me back up. Let's not show you exactly what's happening under the hood. Let's show you a very generalized idea of what's happening under the hood. Because if we got into the very specifics, the very mechanics of what's taking place within the CLR when you actually run your application, we're going to be here for a long time. So that is the goal of this video, to demonstrate the difference between value data types and reference data types. But we're going to do it in a very unique way. What I'd like to do is demonstrate a very generalized overview of what happens when you execute your application in Windows. The application that you write in C#, when you run it, what actually takes place. We're going to trace through it. We're going to show you a method actually running, what happens when the code within the method executes, and what happens with our memory. That's the most important part here, because that is going to allow a very clear understanding of the difference between value and reference types, because we're going to see what's taken place on the stack and on the heap. Two different memory locations that we're going to be dealing with when we take a look at this. All right, so the first thing I want to do is I've got a very simple application that I've written that has no true meaningful functionality. It just allows me to demonstrate value examples and reference examples, and that's it. So let me go ahead and write that out first, and then I'd like to kind of trace through it, if you will, in giving you that big overview of what happens when you run your application and the method is executed. So let's start out with the value example. So starting up here, now I'm going to need to write kind of small for all of this to fit. So we're going to start out with an integer, because we all know that the integer is a value data type, because I've already said it half a dozen times. So an integer x. Now let's turn around and create an integer y. Now let's have a little bit of fun with this. Let's put a value in x. So we'll initialize x to the value of 8. Now for y, how about let's take what is in x and put that in y. Simple enough. Now let's take y and affect it again. Let's set it to something else, like, I don't know, 6. Because 6 sounds like such a cool number. All right, now, with all of this manipulation out of the way, let's write the results of x out to the console. So console.writeLine. And we'll say something along the lines of x equals, and I'll just simply say plus x, like that. All right, very nice. This concludes our example of a value data type. Now we need to do a reference data type. For a reference data type, we need an object. Well, to get an object, we need a class that we can instantiate into an object. So let's go ahead and come all the way down here to the bottom and create a class real quick. Now remember, all of my code, let me grab a pointer real quick. All of my code that I'm creating up here is going to reside inside the main method. Keep that in mind. What I'm creating down here, this class, is not going to reside within the main method, okay? So I just wanted to say that real quick. So coming down here, we're going to say class. And I'm going to create my own version of an integer. We're going to call this myInt. All right, let's go ahead and fill in the class. Inside this class, we're going to have one public data member. So a public int, and let's give it a very creative name, num. Yeah, there we go. That is a completely legit class. Very simple. It doesn't do anything meaningful. It just holds a single integer. But hey, there you go. Now let's use it. Let's jump back up here and continue on. So this next section is going to, once again, it's going to reside inside our main method, but this time around we're going to focus on reference data types. So we'll start out by creating another variable, but this variable is going to be myInt. So it is of type myInt, and we're going to use a capital X, and I'm going to do myInt, and we're going to do a capital Y. Now you'll notice up top right here that we had created variables using lowercase x and y, and now down here we're creating variables using uppercase x and y. Recall back to our basic discussion of variables that because of case sensitivity, these are indeed different. Lowercase x and uppercase x, two different variables. The only reason I'm doing that in this particular example is just because the two examples, the one being the value data type example and the other being the reference data type example, I want the meat of the examples to basically be the same thing. So by keeping the names the same, just changing the case, it's going to be very easy to visualize what's going on. Okay? So now that we've created these two new data types, let's go ahead and instantiate the class into an object. So we're going to say x equals, so now we need to come in here and actually create it. So x equals a new myInt data type. Terminator. And y, capital Y, equals new myInt. Once again, so there we go. Now we have two objects, fantastic. One being stored in X, one being stored in Y. Aha, hopefully I just got you. They're not being stored in X and Y. A reference to those objects are being stored in X and Y. Now let's go ahead and manipulate the data member inside of the object X and Y the same way we did all the way back up here. So let's do this exact same thing right here, down here with our new variables. So let's start out with x.num equals 8. Terminator. And then let's do y, again following the example, is going to be equal to x. And then the next thing we're going to have is going to be y.num equals 6. Terminator. Okay? Very good. So this example right here, we are in essence doing the same thing that we did all the way back up here. Okay, so this guy right here, same thing that's going on up here. Look at this. 8x6, 8x6. Very good. All right, so now that we've got that, let's just simply go back to our console. So another console dot writeline. And once again, we're going to say x, but this time a capital X. So x is equal to plus, and let's gain access into x. So x.num. All right, just like such. And just so that there's no confusion here, because of the way I love to change my casing when I'm just writing, let's go ahead and make that capital. Because somebody might be going, wait a minute, I'm all confused now. So Y, capital Y, dot num. Okay, so good. Now, as I had said, everything here and above is all taking place inside of the main method. And then, of course, our class resides outside of it. So nice and clear, right? Well, hopefully. Now, how do we know the difference between the value data type and the reference data type? Well, let's put the gears into motion and show you what takes place when we launch our application. So I'm going to divide my screen up a little bit, Logan. Just hopefully that'll make things a little easier to draw. So maybe right about here. I'm just being picky for a second. Whoo, look how close that was. Awesome. All right. Now, the first thing that's going to take place when we launch our application is the process starts. So let's go ahead and just draw out a giant process, okay? So here we go. We'll start somewhere over here. Come all the way across like this. This will be our giant process. Let's see if we can carefully go down here without having our window jump all over the place. And then over here. And then finally, up here. And we managed to jump. 10 points for Buzz and his drawing skills. All right. So with that jump, let's go ahead and slide back over just a little bit. And this is our process. All right. With the process now being started, the next thing that happens is our CLR is loaded into it. So here comes the CLR. Everybody remembers what that is, right? The Common Language Runtime. Our virtual execution machine, this is the guy responsible for actually taking our intermediate language code. Remember, that's the compiled code that came from the C# compiler. It's responsible for taking that IL and converting it into what? That's right, if everybody said, our native CPU instructions. So the CLR has now been loaded. But wait, there's more. The next thing that's going to happen is a managed heap is initialized. A managed who? Don't worry, I'll explain this in just a second. So let's draw this guy out. So let's see, give myself a little bit of room, but I don't want to take up too much. So maybe something like that. And we'll come on down to here. Yes, my hand is so steady. These are the most incredibly straight lines you have ever seen before. There you go. So this right here, again, is the managed heap. It's called managed heap because we've got a garbage collector that goes in there and cleans things up and all that good stuff. But it is just the heap. Well, what is the heap, Buzz? It is an allocated section of memory that we are going to be storing our objects in. Okay, we're going to be storing data structures over inside the heap. So what is the heap? It is a place for us to store data. Just keep that in mind. That's it. So now that the heap has been initialized, the CLR has been loaded, the next thing that's going to happen is our thread gets created. And this is for actual code execution now. So here is our true thread. Okay, now my line drawing skills have diminished. And with every thread, they get a thread stack. So what happens is we get a 1 megabyte stack allocated for this thread to use. So let's go ahead and draw out the stack. And I need to give myself just a little bit of room here. I'm being picky once again. So maybe right about here. And we really don't need to go far down. Stack always starts at a high address and works its way to lower address. So I'm basically going to start from the top and work my way down. So you can say that this is a high, let me grab my pointer. This is a high memory address right here. That's why I'm going to draw it this way. In a lot of books, you'll actually find people showing the information or the data being stacked upwards. That's fine. But I'm going to draw it from top down because that's kind of a better representation of what's happening in memory.
In this case, we're drawing out memory because we've just drawn out a heap. So we're just trying to keep with memory.
Exactly. So continuing on, let's write the word stack up here. All right, at this point, I'm sure I've got some people nice and confused, but it's about to become clear after I confuse you for just 120 more seconds. That's right, because now at this point, our foundation's kind of been set up for the execution of our application. So execution now begins. But what happens? Now, we talked about this back in the .NET lecture in Volume 1. We said that when you run an application in the .NET framework, your methods are JITted on the fly. Such a fancy word. Just in time compiled as they are called. In this particular case, what method are we calling? Well, our entry method. It is our main method. Right now it resides as IL code. It needs to be compiled into native CPU instructions, the native language for our CPU. So the CLR steps in and says, all right, this has not been compiled. And once again, I am talking about all of this stuff over here. None of this is being, so it compiles all that, okay? But in compiling, what it does, the CLR actually looks down through here for the different data types that are being used in this method. What data types are we using? We are using an integer. So let me just, this is kind of going to serve as my, here we go. This down here is my notepad. All right, so that does not exist in memory. This is a notepad. We're using an integer, and we are scanning on down the list even further, looking. We are using my int, which actually references the integer data type, if you want to get real fancy. So these are the two things we're doing. Well, what really is int? Okay, well, int, that's just an alias for an int32. And we talked about that way on back when we were talking about .NET and the CTS and all. So we have an int32 that we're actually using. So as the CLR looks down for all the data types that are being used in this method, it then creates a data structure for these different types. And the way that's done is it's based off of information that's being pulled from our metadata that's in the assembly itself. And that's something I'd like to talk about in a more advanced lesson a little bit later, because it's very cool what's taking place here. But it creates a data structure that is a type object of that type, and it stores it on the heap. So we're using an int32. So let's go ahead over here on the heap and create an int32. So this is an int32. And it has some very interesting and useful information in it, but I'm going to draw a little line right there because the one thing that's interesting is that object type pointer that resides, a little bit of overhead that resides in all the objects that sit on the heap. I'm not going to get into that right now other than to use it as a pointer in just a second. You'll see what I'm talking about when I get there, but I'm going to draw the line just to represent that a pointer piece of information goes in there. If right now, if you're sitting there drooling, looking at the monitor going, that's okay. That's okay, I promise. This stuff will slowly become more and more clear. All right, so we've created one of those. What else needs to be created? Well, we're going to be creating my int. So that data structure is created over here. And so here we go with a my int. And for those of you that are taking notes and all, I can go ahead and write out the rest of this. This is a type object. Same thing up here, type object. I was just going to go TO, but then that'd look too confusing, right? Right. Okay, so those two things now exist. Of course, same thing I'm going to do right here is I'm going to come in here and remember a little bit of pointer information right there, and which is actually populated, and this guy up here is populated with information. And, oh, as much as it's killing me to explain to you what's happening because it's so cool, I must hold back. Talk about it later. Okay, so now, at this point, we now have the data structure set up over in the heap. We haven't even began actually executing our code yet. We've gone through, the CLR has set this up for it. It has finished compiling our method into basically into native CPU instructions. Now, finally, the thread, it executes the method. So the method executes. What happens when a method finally gets to execute? Well, it doesn't actually execute right away. The first thing that happens is almost every method has some prologue code. Just a little bit of overhead code that does some setup type things for us. So this prologue code for the main method here is going to execute first. Well, what is it going to do? Well, two important things for us right now. The first thing it's going to do is it's going to scan down through the method itself, and it's going to look for all of the variables that we're going to use. And with these variables, as it sees them, it's going to allocate space for those variables on the stack. So let's pretend we're now doing the prologue code. So coming through, The first thing is we're going to, as we scan down, we see x, an integer value x. I'm just going to write a little x right here, but if I had the space to write it all out, I'd actually write int x just to remind you of the data type, the information type that can be stored in there, okay? Because we're dealing with a 32-bit integer that can be stored on the stack in this location. Now, butt it right up next to that, the very next thing that we encounter when working our way down through with the Prolog code, looking at our code within the main method, is the y integer variable. So that variable, the space for it, is allocated. The next thing, as we continue working our way down, is, and let me go ahead and grab my pointer real quick, so working our way down, aha, two new variables are created, the capital X and the capital Y, and they're both of type myInt. Now, as we look all the way down to the rest of this, we have no more variable types that are created, so let's go ahead and draw the capital X and the capital Y. There we go. So hopefully everybody can easily distinguish between all of these variables by looking at the stack. I'll even make the two object ones a little bit more bold. All right, so the Prolog code has now allocated the space for us over on the thread stack. What happens next? Prolog code's not yet done. It now initializes this stuff for us. So it's going to come down here, because remember, everything's safe in managed code. That's why it's got to be initialized. We can't just let garbage sit out there. We're going to come in here and we're going to take X. It is a value type, so we're going to start out by setting it to 0. We're going to take Y. It is a value type. We're going to set it to 0. Now, capital X and capital Y, they are not value types. They are reference types, so we can't set them to 0. Instead, we set them to null and null. So that is the information that resides in these 4 areas on the stack right now. Very good. All right, so what happens next? Well, now we've got the Prolog code completed. We can finally begin the true execution of our method. Quite a lot of overhead that goes in, huh, Logan?
Right, well, what it looks like to me is that C# works a certain way and allows you to do certain things with variables. And when you get into real IL code, there's a different set of rules that apply. And what the Prolog code is doing for you is taking things from the C# set of rules and making them work in actual IL rules.
That's right.
That means setting up the stack for you.
Exactly. Okay, so now with all of that out of the way, we finally get to begin execution. Let's follow through it. Well, our variables, of course, are already defined, so let's begin right here. X equals 8. Yeah, we finally get to do something. Coming over to the stack, I'm going to simply cross out as opposed to erasing, and I'm going to put an 8 over here. The next thing that's going to take place, looking at our code as we work our way down, is going, as a matter of fact, here's a better way to do it. I'm just going to simply come over here and do a big fat black dot to indicate where we were at. So X equals 8. Now we're going to come down to here. Y is set to have the contents of X put into it. So X is 8. So that means Y becomes 8. The very next line down, Y is then set to a value of 6, which means the 8 goes away and is replaced with a 6. Then coming down, the very next thing that we're going to do is write out on the console the contents of X. So here is our console. So X equals, and what do we have in X? 8. So let's put 8 over there. So that's what we should have printed out when Logan actually creates this in just a few minutes. All right, so moving on down from there, of course, we already have our types here created. So moving on down, or our variables created. So moving on down, the next thing that we're going to run into is the actual creation of the object of type myInt, and then it's then assigned to X. See, I've got to be really careful how you say that, because you want to say, we create the object X. You don't really create the object X. X is just a reference pointing to a particular object at this moment in time. Does that make sense?
Right, and another thing is you want to say things like, all right, we're going to make this and store it in. It's like, well, where are we really storing things?
That's right. So here's how this works. We are going to create an instance of the myInt object type, or type object over here. So here we go. We get an instance of it. And I'm just going to draw it right here. And he's got a little piece of pointer information in there. And guess where this, I'm going to get to draw this out finally. This guy is pointing back to him. Okay? So he can always know of what type he's from. He's pointing back to his type object. If myInt had methods in it the methods would not reside over here in this new instance. All the methods would reside in here. Okay, so if we said something like myInt.execute or .print this or whatever, had some method defined, we would actually come back over here and use this method table to look up that particular method to execute the code for that method. All right, that's definitely getting above and beyond. I just wanted to draw the little line in there. So there's the line. It's associated back with the myInt type object itself. This will become important, though, later on when we start talking about static members and all, because where do you think static members get stored? Not over here in the instances. Aha. Okay, I'll just leave that as a cliffhanger. We'll come back to that later. All right, so now that we have created this guy exists at a particular address in the heap. So let's just say that his address is ADD1. I'm not going to write out a true address here because it's going to be crazy big to begin with. So ADD1, that means address number 1. So now I will use the eraser. So after this line right here, so let me get my pointer back over here. So this guy right here, new, after creating the instance, is going to return back the address to that instance. So now ADD1 gets stored right here. So ADD1. Check this out. ADD1 is a reference pointing to this object.
Because if you look at that address, what you will find is that instance of that object.
Precisely. Now, the next line of code is going to create, so let's go ahead and show where we are executing at the moment. So this line of code right now is going to create another instance of the myInt type object. So here comes another instance. Same thing. This guy points back. So that's pointing back. There you go. And he is at his own address within the heap. So let's call this ADD2. Once again, that is what gets stored in Y. So ADD2. That means that this guy is a reference pointing to that object. So we're pointing from the stack over to the object which resides in the heap. So far, so good. So remember, it's new, creating that new instance that returns back that address that gets stored into there. Now, let's back up just a second. When we ran those two lines, when these instances were created, here's the way the CLR works. The instance is created, and when it's created, it also goes through and it sets up, guess what this is? Num, our data members. And it initializes our data members. It has to do that. So what is this? It's an integer, so it's going to initialize this value type. This is so cool. This value type that's now residing on the heap.
Right, because I was about to point that out. If you look before, with X and Y earlier, we had integers stored directly on the stack.
That's right.
Now we have integers stored in the heap.
That's right, within their object. So this guy gets initialized to 0, and the same thing happens down here. He has his own num. And it gets set to 0. Okay, very good. So now, finally, let's go ahead and run this last section of code. So now we're right here. So on this line, we're telling it x.num. All right, well, x.num. So that means what object are we pointing to in x? This guy right here. Set his num to 8. So now we're actually going to come in here and we're going to set num to a value of 8. Very good. Next line that gets executed. This is where it's at. This is something that confused a lot of people back in the Hyperion project when we would create a room and then we would pull a room out and set the one room equal to another room. Remember that, Logan?
Right. Well, that would have been in some of the level design code where
That's
we keep reusing room over
We kept reusing room, but people would start to get confused as to, well, how's this room pointing to that room? It was another room. I'm confused.
And what happened to the old room?
And what happened to the old room? Here you go. Check this out. On this line right here, we're saying y equals x. All right? That means that y, instead of holding ADD2, it's not going to hold that address anymore. We're simply going to take the contents of the x variable, which is address 1, and we're going to put that into y. Address 1. That now means, this is so important to understand, that we are now pointing over here. Let me work on my line skills. So we're pointing this way. This way. Ooh, what about this other line? I'll tell you about this other line. I'm going to erase it. Uh-oh, we've just created a very, very interesting situation. We just lost our reference to the second instance of myInt that we created. It's gone. We have nothing to let us know how to get back to it, period. It is gone. If we wanted to know how to get back to it, we would have needed to have stored it in another variable somewhere. We didn't do that. This guy is now sitting out here in limbo. He's no longer being referenced. He's no longer being used. Now, at this point, you have heard the term garbage collector just a couple of times, all the way back in the .NET lesson when we were talking about how the CLR works, its managed code, and how you have a garbage collector that comes behind you and cleans things up. Well, here you go, a very basic example of where the garbage collector comes in. Every now and then, the garbage collector is going to walk his way through the heap and say, all right, let's take a look at what we got. Hey, this guy right here, is anybody referencing him? Oh, yeah, somebody is. All right. This guy right here. Is anybody referencing him? Mm-mm. This guy needs to be collected. He's garbage. He needs to be deleted out. So this guy would actually get removed the next time the garbage collector came through the heap looking for objects that weren't being referenced. There you go. So now you have a basic idea of how the garbage collector truly works. But don't let that fool you. The garbage collector goes a bit deeper than that. But this is just a very nice, quick overview. Okay, so at this point, both X, the capital X, and the capital Y are both pointing to this instance of the myInt data type, or excuse me, the myInt type object, okay? Now, let's move on down to the next line of code. So follow me, I'm right over here. This is important. What do? We say y.num equals 6. Well, who is Y? Well, remember, when we were talking about these instances being created over on the heap earlier, I said it wasn't like this guy was X, right? It's not seen that way. He is just simply an instance of the class. That's all he is. Now, the reason that was X was simply because X pointed to him at the moment, at that particular moment. But now, X and Y are both pointing to this instance. So now, hopefully, you can see a little bit more clearly that Y on the heap, that object wasn't really considered to be X.
Exactly, because you've got X and Y still exist on the stack.
They
all exist only on the stack. That object on the heap isn't labeled X, and that's why you can't find it if you lose your reference.
That's right.
Instead, the reference is what's named X, and it resides on the stack.
Exactly. Very nice, Logan. Very nice. Okay, so with that being the case, to execute this line right here, y.num, well, we just simply look at who we're referencing, which is address 1, and take the num data member in it and set it to a value of 6. That means the 8 gets wiped out and replaced with the value of 6. And then from there, we come down here and we say console, right line, x equals, so we're going to write out x equals, and where at first glance it would look like it would be an 8, because if you take a look at this code right in this area, we never mess with x after we set it to an 8. But because of the way that the reference system works, we are referencing this particular instance of the object right now, or of the class, and what does it contain? So here's x, so let's take a look. There's x. We're following x down to who he's referencing. What's in num right now? 6. What gets printed out? 6, not an 8. There you guys go. There is a very close look at what is happening with your stack and your heap that distinguishes the difference between a value data type and a reference data type. This means I could create, 5 more variables if I wanted to, and all of these variables, they could all easily be pointing at this one guy. That means if I did a scenario like that, adjusting any of these guys would be the same exact thing as if I adjusted any other, because they are all referencing the exact same object. Okay? So hopefully this is clear. If it's not, Don't worry. I would recommend watching it a second time. I know perhaps it might be a little bit more of a complicated concept with, okay, let's see, the CLR gets loaded, and there's this heapy thingy that gets created, and there's this thready thing that gets created, and what about multiple threads? Well, we're not worried about a multi-threaded application right now. This is a very simple application, so bear with me. And then there's this stacky thing. You know, just watch it again. Let it kind of sink in for a day or two. The biggest thing I want you to understand is that with a value type, and those are going to be your simple types, like an integer or a float or a decimal, these types, they fit on the stack with ease. We start working with object types. Object types can be huge, okay? I mean, the interesting thing about these instances over here, they don't contain just the data members, the members that come from this guy, but they also contain the data members that come from everybody that's inherited above the hierarchy above it. Because with object-oriented programming, that's the whole idea, is that each standalone object contains a particular state, and that state is defined through the setting of these data members, okay? So the state of this guy right here is 6 at the moment. And if this guy was still being used down here, his state would be 0. So there's all sorts of information that's being stored in there. All right. So again, value types, nice and simple numbers actually being stored in that. Let me not say nice and simple numbers. I mean, because, you know, a double is going to be a huge, crazy, scary looking number. But you get the idea. The actual data, the value is being stored in there. Reference, it is an address pointing to the heap to where that object actually resides. Okay? Now, Logan, let's go ahead and jump over here. We might have to do some quick cleanup. We do. Go ahead and close that out for me.
All right. And see, let's just close this solution out altogether. And I'll just discard this one.
Let's go ahead and write it up real quick. If it's going to, there it goes. Give it back to us. At this point, for those of you that have a complete understanding, you may exit out if you want, but we're just doing this for our complete beginners.
Right, just give an example of everything actually in motion.
That's right. So let's go ahead and create a new console application. Looks good.
All right, it's already set to console application, so we'll hit OK.
All right, so let's start out and start creating some of these guys. First thing is int x.
All right, we'll begin with our value example, so we'll make an integer x.
Okay, then int y.
And we'll make an int y.
Now hit enter one more time. Let's space these things apart here. All right, say x equals 8.
All right, x is equal to 8.
All right, put y equals x.
Y equals x.
And then let's go ahead and set y is equal to 6.
All right, y
and
is
enter,
6.
enter. All right, now go ahead and do a console.writeLine.
All right, console.writeLine.
And inside it, put x equals.
All right, x equals, I'll put a space, I'll put another quote.
And then just say plus x.
All right, plus whatever is in x.
Yep, and Terminator. All right, very nice. And let's go ahead and hit enter one more time, and go ahead and do a read line right here just so that we will hold our execution up long enough for us to see what's on the console.
Okay. So we'll do a console.readLine.
And let's run it.
All right. So if we run, we get this. X equals 8.
It's exactly what we had back over on the whiteboard. Okay, as a matter of fact, go ahead and close that, Logan. I'm not going to jump back and forth a whole lot, so don't panic when I do this, but I do want to show you. Here we are. That's the very first thing on the console. We see x equals 8. So far, so good. So the next thing that we should see when Logan finishes this off is x is being set to a value of 6. So let's go ahead, Logan, jump back over into Visual Studio. Now, let's go ahead and define our class first.
Okay, because we're going to need that in this example.
Yep.
So just as you had it drawn before, I could jump below class program, and we'll make the myInt class.
Mm-hmm.
So this is simply class myInt. And then we'll put the brackets in. And inside of my int, we have one public data member. That is going to be the public int num.
Yeah. Creative naming. All right, now let's go ahead and go back up between the two console. There we go. Hit enter. Yeah, beautiful. All right, so let's go ahead and start out with a myInt declaration for the variable x.
So we've got a myInt x and then capital X as you had drawn before.
Very good. A myInt capital Y.
All right, myInt y.
All right, now let's go ahead and jump down. And now we're going to say capital X equals new myInt.
X equals new myInt, open closing parenthesis, and Terminator.
Okay, and then same thing for Y.
Y is equal to new myInt. All right?
All right, beautiful. All right, so let's go ahead and jump down with X, capital X, dot num equals 8.
All right, X dot num is equal to the value 8.
Okay, and dropping down, y equals x.
There we've got y equals x.
There we go, throwing that reference from the first one first one into the second variable, and we're now losing the reference to that second instance of my int that we created. All right, so now let's go ahead and set y's.num.
So y.num
to 6.
is equal to 6.
All right, beautiful. Now let's go ahead and do the console write line thingy again.
Console.writeLine, where we will write out x is equal to, close the parentheses, and then we'll add on to that x.num. And there we go.
All right, so at this point, if Logan runs it, we should see 8 in the first one. We should see 6 in the second one because both x and y are pointing to the same object, and the value 8 was overwritten with the value 6. Let's run it. Woo, there we go.
Lowercase x is 8 and uppercase x is 6.
All right, so go ahead and close that out, Logan. So 8 and 6, and if we come back over here, there we go. We got exactly what I said we should get. So 8 and 6. All right, ladies and gentlemen, that's going to bring this video to a close. Hopefully at this point you at least have a very basic understanding of the value types are being stored over on the stack, and a reference type simply is a reference being stored on the stack pointing to the object that is over in the heap. And with that, Logan, is there anything you'd like to add?
I think that pretty much covers it. Just something to keep in mind when you're working on reference types. And you have to keep in mind what is the real thing that this is actually looking at. Because you might have value types where you're looking at x, and x is 8 right here, right now, only 8. But if you start passing reference types around, you have to keep in mind that they might all be pointing at the real whatever object that they are pointing at.
Precisely. All right. Well, with that, that is going to wrap up this video. Thanks a lot.